So we are going to be taking the other ones, and I'll be fast now since I've already laid the foundation in the first video. So this one, B, is triethylene chromium 3 chloride. So I told you that if you are doing that B, you are going to first write the complex ion. You will start with the colibrace. So start with the transition metal, which is chromium. Then the ligand that is present there is ethylene diamine. Ethylene diamine is symbolized as En, but they put a previous there as tris. Tris means three in Greek. Then that's the only ligand. Then there's this chloride standing ahead, standing separate, and that's the cation. Since it's coming at the back in the name, it's also going to be at the back. But I told you that the number of cation that you will write from the name is not depicting the actual amount. So you have to get how much chlorine should be outside. Is it 1 or should it be more than 1? And I've told you that the formula is Cc equals to oxidation state of metal plus ligand. Since the magnitude of your cation equals to charges on complex ion. Charges on complex ion. That means if you can get your Cc, charges on complex ion, so you can actually get the magnitude of your cation. Since this formula, this is my hypothesis, Phillips hypothesis, says that magnitude of cation equals to charges on complex ion. So once you can be able to get charges on complex ion, you can get the magnitude of the cation. Now let's calculate. Charges on complex ion is going to be oxidation state of metal. What is the oxidation state of the chromium? It must have been given in your naming. They said chromium 3. So that means what will come out of here, oxidation state of metal, will be plus 3 plus your ligand. You have to know the nature of your ligand. Ethylene diamine is not a charged ligand, it's a neutral ligand. So that is going to be 0. And 0 multiplied by 3 is going to be 0. Then that's what you have. That means charges on complex ion is plus 3. That means what is here is 3 plus. So if you serving as a cation, you are the chlorine now, you have to be the magnitude of exactly the charges you are to counter. So if the complex ion is counting 3 plus, then that means you must also be 3. So once you have this 3 correctly, this 3 has deleted this 3, then you can have your answer. So the correct answer to that question B is Cr into En into 3, ethylene diamine 3, then Cl3. So the number of chlorine required to get for us to use is chlorine in 3 places. I hope you understand. Alright, let's take C. C says that tetraamine sulfato-cobalt 3 nitrate. You have to first write your complex ion first. Write the central metal first, which is the cobalt, and write all the ligands. The ligand there is sulfato and amine. So according to their spelling, so write amine first, NH3 into tetra. They said the amine is tetra, which is 4. Then you write sulfato. Sulfato is SO4. And sulfato does not have any previous, just write SO4. Then you close the colibrace, and then you put your nitrate. Nitrate is NO3. Now, I said that this nitrate is the cation, but you don't know the magnitude. And magnitude of a cation equals to the charges on the complex ion. So once you can be able to get the charge on this complex ion, you can depict how much should this NO3 be. Now, and I said that Cc equals to OM plus ligand. Cc, which means charges on complex ion, OM, oxidation state of metal, and ligand. So what's the oxidation state of metal? It will always be given in your naming. They say chromium 3. That means the OM is plus 3. Then our ligand, you will check the nature of the ligand inside this. NH3 is amine. Amine is a neutral ligand, so that will be 0. Plus, is 0 times 4 is 0 now. So SO4 is actually a 2 minus ligand. Don't forget that, as in H2SO4. So the reason why SO4 requires 2 hydrogen is because it's 2 minus. So hydrogen is serving as a counter here. So that means anywhere you see SO4, you know that one SO4 stands for minus 2. By the time you do that, that will be 3 plus 0, that's 3. 3 minus 2 will now be what? 1. That means the charges on this complex ion is plus 1. That means you will be correct if you just leave this NO3 like that. So we only need one NO3 to counter this complex ion. I hope you understand. So let's take example. Let's take the 4th example. I get you. Are we ready? Just give me it now. Okay. So we are going to be taking the fourth example now. Trichlorous bees and lead. So the first thing is to draw your complex ion polymerase. So write the center metal inside. The center metal here is chromium. You write your Cr. So they said dichloroethylene diamine. You arrange them alphabetically. So the first one is amine, which is ammonia. So and they said it is actually okay, it is ethylene diamine. It's not ammonia. Ethylene diamine. So start with chloro. Chloro will be Cl2 because they said it is dichloro. Then they said bis. Bis in Greek means two, di, and ethylene. Why are we using bis? Because already in the ethylene diamine, which is a ligand, it has already carried di. So we now saying ethylene diamine is as if we are repeating di too much. That's why we have to go to Greek and use bis instead. So whenever you see bis, bis means di. That's two. That means our ethylene diamine is bis, which is two. Then you close your polymerase. Then you now put the counter-ion, which is chloro. But I told you that this counter-ion is not always the correct figure. You have to cross-check. And how do you check? The magnitude of your counter-ion is a measure of the charges on the complex ion. So you have to determine what is the charges that this duplex, this complex ion is carrying. And how do you get that? Charges on complex ion equals to OM, oxidation state of the metal, which is the chromium, plus the ligands. Now, CC now equals to oxidation state of metal must be stated in the question. You will see a number there. A number must always come. That is what? Plus 3. Then plus ligand. You have to know the nature of the ligand. That's why you have to go and study. You can pause this video or after this video, go and study the neutral ligand and example of anionic ligands. Ligand can never be positive. It's either they are anions, negative, or they are neutral. Even water is a ligand. You have to know, but water is a neutral ligand. So this chloro is not a neutral ligand, it's a anionic ligand. And one chloro means -1. We have 2 here. That means that will be what? -2. Then ethylene diamine is a neutral ligand. It's going to be what? 0. 0 times 2 is still what? It's still 0. By the time you do this, that will be what? 3. Plus times minus is what? Minus. 3 minus 2 will be what? That will be 1. That means the charges on this complex ion is +1. That means there's no problem by leaving this question like this. This is the correct form. Because since I'm having +1, the number of chloro, the magnitude of the counter-ion will still be 1. So that means this is correct. You get it? So thank you. Please try to subscribe to this channel for more videos. I'm going to solve the second part in the next video. Thank you so much.